All right, hey everybody. Welcome to the Unity session, and we're going to be basically creating a platformer game. So first off, I don't want you guys to get put off by the name Unity 3D. It's got a 2D tool set too, so you can actually create 2D games. And let's do a quick run through about what Unity is all about. So it is a powerful and flexible engine, and it is the preferred option if you're looking at SpriteKit and SceneKit on iOS. I mean, that's great if you're familiar with iOS developments to create some games. But if you want to do professional games, my recommendation would be to look at Unity and get into that. So it is really easy to pick up for beginners. Hopefully you'll see some of that today. And it is definitely powerful enough to create some AAA games. And there are AAA studios that have released quite a few games with Unity, some examples being Hearthstone and Firewatch, for example. And the best part about Unity is it's multi-platform, so you can use it to build games for PC, Mac, Linux, consoles, mobile devices, and you don't need any special requirements for that. For those core platforms, you can just build and run your game across them, which is the best part in my opinion. And of course, it's free to use and to develop and to release your games and make money on them. I did put a little asterisk there on the free part, because once your company makes about $100,000 in a year, I think you do need to give a small kickback to Unity for licensing. There are also some subscription models that you can pay for, a monthly fee, and they give you things like cloud build support and analytics and some more advanced things that you can use, but they're definitely not required to use Unity to its full potential. So I thought I'd quickly run through some alternatives to Unity in terms of other engines out there. We've got Unreal Engine by the guys at Epic. They make games, if you're a gamer, games like Unreal Tournament. They're famous for that. They've now got this Unreal Engine. It's really graphically powerful, but you do need to code in C++, so that's the one downside in my opinion. And the community around Unreal Engine isn't as big as Unity in my opinion, which is a very strong point for Unity. We've also got CryEngine by the guys at Crytek. They make games like Far Cry and Crysis originally, and Star Citizen is an example of a game that's using CryEngine, but again, C++ and not as big a community, so community support isn't as great. And then of course we've got SceneKit and SpriteKit, as I mentioned earlier. They're great if you're good with iOS development and wanting to do some simple games, but for professional games, definitely look at Unity in my opinion. So let's run through some quick basics on how to use Unity. So you've got something called the Unity editor, which is hopefully what you guys have already launched and checked works. And that's where you do all your visual editing. You set up things called scenes, which are kind of like levels for your games. And in those scenes, you create game objects and you attach scripts and components to your game objects and structure your game using that editor. You can also use it to hook things up and set references between different objects. And then, of course, you've got your own custom scripts, and you can write those in C#, which is what we're going to be using today. You can also use something called UnityScript, which is a derivative of JavaScript, but only a very small percentage of developers still use that. So C# is definitely the preferred language. So once you've written your scripts, you can attach those to game objects in your scenes, and this is Unity uses an entity component system. And this basically allows you to create really modular game objects for your games, which is a really cool part. And then, of course, you can play and test your game in the editor itself. You don't actually have to build for a platform and then run your game. You can actually run it directly in the editor, and you can dynamically change variables and parameters on your game objects, which is great for feedback and sort of planning out your game and balancing gameplay. And then, of course, we can deploy to multiple platforms and just have one single code base, which is the brilliant part. And to give you a practical example, I've got a small game that I developed initially for Android using Unity. About a week later, I decided, hey, I want to release this on iOS. So I put a little bit of code branching in for Game Center, added Game Center support, and compiled a version for iOS, put it through the Apple process. And within a week or so, it was on the iOS App Store with the same code base, which was brilliant. All right, so demo 1 that we're going to get to next, we're going to look at doing some editor basics on how to use the Unity editor and coding a basic character controller. So we've got a character we're going to drop into our game, and he won't actually be able to move or do anything like that. And what we're going to do is write this controller that will allow us to process input from the controls and actually move them around. And demo 2, we're going to go more advanced on that controller and allow them to do more tricky things like jumping off walls and things like that. And in the lab, time permitting, we'll hopefully look at designing a custom level with the editor. Okay, and let's take a quick look at what we'll be making. So hopefully this YouTube video loads. This is a custom level that I created with the actual the code base that we're going to be creating today. And unfortunately, I don't really have sound. Let's just see if I can bump it up. But anyway, you get the idea. It's basically a Super Meat Boy clone, if you've ever played Super Meat Boy, and allows you to jump around on these platforms. And being the evil level designer I am, I've put in these saw blades that spin around. Ah, there comes the sound. And basically cut you up and gut you into little pieces of soy. So the play on the character here is he's a piece of soy, so he's kind of like the opposite of Meat Boy. So he's sort of like the vegetarian option, I guess. Okay, so just a quick reminder before I forget, if you're new to C#, if you're coming from languages like Swift where you don't end with semicolons, don't forget that in C#, you've got to end every line with a semicolon, or every sort of block of code finishes off with a semicolon, and it is the hide-and-seek champion since 1958. He will basically hide away from you, and you might get a compiler error, and if you're not used to them, you don't know which line the error is referring to, you might not see that you've missed out a semicolon there, so don't forget that. Okay, so let's jump into demo 1. So if everybody can just launch Unity if you haven't already, and you're going to get a splash screen up when that does load. And what you're going to want to do is you want to point. So I'm just going to launch Unity here so you see the same screen. So we've got that splash screen that's going to come up, and you're on the Projects tab. We're going to go to Open, and you want to select the starter project for demo 1, which is in the content from the conference content for this tutorial. And go into the starter project, and then select the Super Soy Boy folder within starter for demo 1. And you should have a select folder or an open button at the bottom of the Finder dialog. I assume everybody's on Mac here. Please don't get put off by the fact that I'm on a Windows machine. Unity is going to look identical to you. I am the black sheep of the conference, I think. I don't think I've seen a single Windows machine. So just select folder, and that's going to basically open up the project into Unity. It might take a few moments to load, but once it has loaded for you and opened up in the editor like this, if you can just raise your hand and let me know that you're at that point. So I'll just give everybody a few moments to get to that stage. Now, what it's going to do while everybody's loading up that, it's going to load you up into a blank default scene. And I want you guys just to take a look for the layout button at the top right corner of your screen. And if you click on that, there's a default option in there. If you select that for me, it's going to basically reset your editor to the default layout so that everybody's using the exact same layout. And it should look something like that. You've got all the windows docked in the same sort of areas, which is the default layout. All right, how's everybody looking? Has everybody got the... If you raise your hand, if you've got the starter project open. All right. So let's start off. If you are a little bit behind, not to worry. This is going to just be a temporary scene that we're going to play around with. But what we want to do is look down in the bottom of the project window, and that's this bottom panel right at the bottom here. And we're going to look for the resources folder. And if you expand that out, underneath that, you've got a complex folder. Now, inside this is a series of objects called prefabs. Now, prefab is like a template in Unity. You use these to define a sort of baseline setup on a game object, and you can clone them and bring them into your game scenes. And it's basically like a template engine. So what we're going to do is click and drag on the first one, which is called Platform Type 1. Drag and drop it into the middle of your scene here. Let go your mouse button, and it's going to create in your hierarchy here on the left-hand side a platform type 1. Now that's a game object, and that's a clone of this prefab template. And what we can now do is we're going to use the move tool to learn how to move things around in the scene. So the shortcut key for that is W on your keyboard, or if you click on this little tool on the top of the toolbar here, and you're going to see this little blue box in the middle. It's called a gizmo. And if you left-click and drag on that, you can now move the game object around in your scene. So if you look over to the right of your screen in the editor now, you've got this inspector panel. And this has got, basically, you see this component called a transform. Every single game object in Unity always has a transform. It allows you to position, rotate, and scale objects. So if you just enter 0 values for the X, Y, and Z components on the transform, what that's going to do is it's going to center the game object in your scene. And what I want you to now do, assuming everybody's on a Mac, is if you make sure your move tool is still selected, hold down Command on your keyboard, and try and move that object around by left-clicking and dragging that middle blue box around. And watch your values in the inspector as you do this now. You'll see that they now snap to a grid, and your object snaps to 1 point every time you move it. Now, the default grid size in Unity is 1 by default. And it's important for our platforming game because when we position platforms, we want them to sort of sit next to each other perfectly. We don't want any weird gaps or spaces in between. So it's important to be able to snap to a grid when you're designing your levels. So let's just change our position back to 0 with our platform type 1 selected. And back in your complex folder, in your project window down here, you can see the fourth object is called platform type 4, and it's got that saw blade. If you click and drag that into your scene, that's going to drop a copy of that prefab in. And then with it selected in your hierarchy window here on the side, on the left, you can see your transform components again in the inspector panel. Set that to 0. And then click on your move tool up here again, and holding down Command again to snap it to the grid, we're going to move it over to the side. And you can see how it will now snap next to the other one, which is hopefully still centered. And that's basically just shows you how you can stick things next to each other nicely. Now let's quickly run this game. So to do that, it's pretty obvious. There's a nice big play button at the top. So if you click on that, it's going to switch to the game view. And you'll see basically what the camera in the game is going to see at this point. And this saw blade rotates. It's just got a custom script that just rotates at every frame of animation. So don't worry about that for now. But that's basically what the game looks like at the moment. So click the play button again to stop the scene. And what we're going to do at this point is we're going to open up the included game scene in the project. So to do that, in your project window at the bottom here, select scenes, and we're going to go to game and just double click on that. And just choose don't save when it asks you to save changes. And that's going to open up the game scene. So at this point, if you've got to that stage, if you can just raise your hand for me to see, and I'll just wait for everybody to catch up if you're not there yet. And in the meantime, if you want to try and do a few other actions in the scene editor, make sure you've selected this scene tab over there. And if you want to pan the view around, press Q on your keyboard, or select this little hand tool at the top left corner of the screen. And you can left click and drag inside the scene view, and that's going to pan your view around in the scene so you can look around. And I think it's a 2-finger drag in or out on your trackpad to zoom the screen in and out. For me, it's middle mouse scroll wheel on the PC, but if you use 2 fingers on the trackpad, you can zoom the view in and out. And if you take a quick look around the level, this is a basic level structure that I've laid out that we're going to set our game in. And once you're done, if you just pan over to the bottom left corner of the level in your scene view, and just position your view like that. And what we're going to do now is we're going to drop in the actual player object, Sawyer Boy himself. So to do that, we've got a prefab. If you click on the basic folder under resources in your project window down here, look for Sawyer Boy, left click and drag him into the scene, and just drop him somewhere around here above the platform in the air. Don't worry about him being in the air for now, and let go of your mouse. And you'll see in the hierarchy over here, you get a Sawyer Boy object created. And what we're going to do now is if you just zoom your scene view in and pan it over, he's got a big fat audio icon over him. So if we zoom far enough, you can actually see his sprite. So I just want to show you what he actually looks like for now. Now you'll notice that with him selected in my inspector, I've got a whole lot of different components attached to him. Now we'll go through some of these later on, but for now all you need to worry about is just scrolling all the way to the bottom of this inspector list. And at the bottom you'll see this add component button. If you click that for me, and you've got a little search box that appears. Type in soy, S-O-Y, and you should see the Sawyer Boy controller script appear in the list. If you left click on that to select it, it's going to attach this script or component to the Sawyer Boy game object. And this is what we're going to now look at editing and working on. So to actually edit it, you need to double click on the actual name of the script in the inspector down here. The other way of doing it is to select scripts at the bottom of your project folder and find the Soy Boy controller script and just double click on it to launch your IDE. Now, ignore the fact that I'm on Visual Studio on Windows. You should have something called MonoDevelop that launches on your machine. And once that launches and loads up the Soy Boy controller script, if you can just raise your hand for me and let me know that you're at that point, and we'll continue on from there. All right, so while everybody gets that script loaded up, just remember you select it in the scripts folder down here and double-click Soy Boy controller to open it. I'm going to run through what a script in Unity actually looks like. So every script in Unity inherits from a base class called a monoBehavior, and you can see that over here. So monoBehaviors are they basically give you some base functionality that you can use in your scripts. They do things like lifestyle operations for your scripts, things like initialization, updates for your game loop. There are various callbacks you can use on them too. But for now, the Soy Boy controller script is almost empty. It's almost brand new script. What I've already done is I've added a few variables at the top, width, height, and raycast length check. And all I'm doing is an initialization, which is handled by this method here called awake. This method basically runs as soon as you launch your game, or as soon as this game object enters the game. And it runs any code once off as an initialization. So for width and height, all you need to know right now is it's using the width and the height of the actual sprite of Soy Boy himself. And it's just setting those variable values once off in initialization. We've got this update method. Now that handles updates for your game loop. So it's executed once per frame. And you put your game logic in that update method, basically. Fixed updates is very similar to update. It's just used for physics updates. So it's better to do any physics-related code to move things around with the physics engine in fixed update. We can ignore this helper method down here. It's something I've added that we'll use later on. It's just a convenience method that saves us a bit of time. OK, so what we're going to do now is we're going to look at adding some functionality. So go to the very top of that script. And just below these private float variables fields at the top of the script, just add a few lines. And what we're going to do is add some new variables here. So we're going to start off by typing in public float speed. So we're going to call this speed. And hopefully this is big enough for you guys. I can zoom it a little bit more. And we're going to say equals 14f. So 14f is a float value of 14. Now, ignore these. These are magical numbers for now. They're just what works well with the game that I've found work well. So that's if you see a default value like that, that's what it is. And below this, we're going to add another line, public float accel. So this is going to be an acceleration value. And we're going to set this to a default value of 6f. And then another one below this, private. And I'll explain public and private in a moment if you're new to C#. And we're going to call this vector2. That's a type that we're going to use here, capital V, vector2. And we're going to call this one input. Now, normally a vector is used for things like direction and headings and things. In this case, it's a vector2, so it's in the 2D world. And it's got an X and a Y component. But in this case, we're actually just using the structure to capture X and Y input from our controls. So it's not actually really a vector2. It's just to hold an X and a Y value. Now, below this, we're going to type in private, and then rigid body 2D. Now, it's a capital R, and then the number 2D at the end. And we're going to call this one RB for short. Don't forget your semicolons. And then another one, private and animator, and we're going to just use lowercase animator for this. Now, to explain these last three, actually, there's one more that I forgot. I apologize. So let's just add another one in here, private sprite renderer, or one word, and short SR for short. Let's just call that. So what these last three are going to do here is we're going to cache a reference to these components in these variables when the game starts. So to do that, we use the initialization method. So in your wake method, go to the bottom, add a new line, and we're going to go SR, so sprite renderer, is assigned, so equals, and we're going to use something called get components. So if you type in get components, and then we need to open up these angular brackets, and inside of that, we're going to type in the actual type that we want, which is a sprite renderer. So uppercase S and R, and then a semicolon on the end. Oops, I can't spell. Sprite renderer. So what that's going to do is, on initialization, it's going to get components, basically looks for a component on the game object that the script is attached to. So in this case, this script, SoyBoy controller, is attached to SoyBoy himself. So what getComponent does is it looks for a sprite renderer component on that game object in the game. And if it finds one, it sets that reference. So we're going to do exactly the same for RB. So RB is assigned getComponent. Let's just scroll that up there. And in the pointy brackets, we're going to pass in rigidBody 2D, semicolon on the end. And again, we're going to do the same for animator. So animator, all lowercase, is assigned getComponent, and then pass in animator. Okay, so next we need to actually capture some controls and inputs. So we're going to do that in the game loop. So this is going to be in the update method. So go down to your update method, and we're going to go input.x equals, and we're going to use a method called input.getAxis. And we need to pass in a string to that. So open up parentheses, and in quotes, we're going to put in horizontal. And that's a default axis that Unity gives to us. And basically, if you're using a game controller, it's your analog stick going left and right. It captures input from that. Or if you're on the keyboard, A and D, or left and right arrows. And it's going to capture a value between -1 and 1 based on whether you're going left or right. Okay, so input.y, this is now up and down. This is going to be for jump. Same thing, input.getAxis. And in the axis name, we're going to pass in the axis called jump, which is another axis that Unity gives you. That's when you press spacebar on your keyboard, basically, or A on your controller, for example, if you're on Xbox. Okay, now below that, we're going to type in animator, so our animator variable, dot, and we're going to use a method called setFloat, and we need to pass in a string for this, and you need to type in speed with an uppercase S, and after speed, in quotes, comma, and we need to pass in a value here, which is a float value. For this, we're going to use a helper called mathf.abs, so absolute value, and in brackets, parentheses after that, we're going to pass in input.x. So remember, input.x can be -1 or 1, and we want to always pass a positive value for the speed. And what animator is going to do is it's going to go to the animation controller, which is already set up on this game object, and it's going to set the speed to 1 when you're moving around. What that does is it basically tells the animation to start playing the running animation for your sprite. So your little sprite's going to look like he's running. We're not going to actually cover setting up those animations. All you need to really know for now is that they are set up, and there you just need to actually set the speed value into the controller for it. So below that, we're going to go if, and then open up parentheses, input.x is greater than 0f, so 0 value. So basically, if you're pressing left or right, right, if you're moving to the right, it's +1. And then we're going to open up braces here, and we're going to go SR for sprite renderer, .flipX, so that's a property which is Boolean, which flips the sprites around. And we're going to say is assigned false. And then we're going to go below this brace, and we're going to say else if input.x is less than 0f, we're going to flip the sprite. So we're going to say is assigned true on the flipX property. So that's basically going to flip our sprite left or right. All right, so hopefully everybody's at that point. If you can just raise your hand if you've got that far so far. Okay, now we're going to scroll down to our fixed update method, and we're going to actually write some code to move our character now. So for this, we're going to set up a variable, and to do that in C# you can go var, var, is this, and we're going to call this acceleration. So acceleration, and we're going to set this equal to the accel value that we've got at the top of our class. That's the constant value that's already set. So it's just a temporary variable for now. And below that, we're going to go another one, var xVelocity is assigned 0f, so just initialize it with 0 as a float value. And below that, we're going to say if input.x equals 0 in brackets, and then open up our braces. We're going to say xVelocity is assigned 0, so again, just setting that to 0. And below that, we're going to say else, and we're going to set xVelocity equal to, and we're going to call rigidBody, so RB is our reference to that, dot velocity dot x. So whatever current x velocity our rigidBody has, we're going to set to this x velocity value. Now I'll come back and explain what a rigidBody is in demo 2, but for now, let's just write that line of code in there. And then just below that else statement, if you type in a comment here with 2 forward slashes and just type in to do jump code, don't forget to add that just below this if and else statement. We're going to come back and add something in there later. And then below that comment, we're going to say, this is where we're going to basically calculate a force value for our x-axis and apply it to our soy boy game object. So just to quickly explain that, I'm just going to load up a slide here to explain how to add force. So to add force, we call this method called add force on the rigid body component. And what you need to pass into that is a vector2 value called force. And remember, vector2 has got x and y. So basically, if you look at this diagram, think of you're adding force behind soy boy himself. So we're going to move him in that direction. So that's basically what the force parameter is for the add force method. And to actually calculate that, we're going to make a variable called x-force. And we're sort of working on the law of force equals mass multiplied by acceleration. And what we're going to do is we're going to take our input x value, multiply it by our speed value, which is a constant value, and we're going to subtract the rigid body's current velocity on the x-axis. And it's just to get a nice smooth value to apply as a force. And then we can take all of that, multiply it by acceleration, and add that to the rigid body using this add force method. All right, so to do that, let's go var, back in our code, var x-force equals, and we're going to open up parentheses, and inside that we're going to type in input.x multiplied by speed minus or subtract rigid body dot velocity dot x, and then close parentheses. And we're going to multiply all of that by our acceleration value. Don't forget your semicolon. Okay, so next, below that line, we're going to go rigid body, and this is where we're going to call that add force method. So add force, and we're going to pass in, it needs a vector2 value basically to pass in. So we're going to construct a new vector2. And to do that, we use a new keyword. So new and vector2, open parentheses again. And what we're going to pass in is our x-force value. And then for our y component, for now, we're not going to bother with working that out yet. We're just going to put in a 0 for the y value. Close parentheses and semicolon. And then below, just type in another line, rb.velocity. And we're just going to manually set this. So to manually set it, we also need a new vector2. So new vector2. Open brackets, pass in x velocity as the x component. And for the y component, so comma, rb.velocity dot y. Okay, so you should end up with something like those 3 lines there. And if you save your script at this point and return back to the Unity editor once you get there, I'm just going to leave the code up for a little bit longer while everybody saves their files and copies that down, and switch back to the Unity editor. So if you can raise your hand if you got to that point. All right, great, let's do it. Okay, so back in the game, I'm just going to zoom out the scene view. And if you click on the play button in the editor here, it's going to launch the game now. And your soy boy controller character should drop down onto that platform. And if you press left and right, you'll see that he actually runs left and right now. You can even run into that item there if you want to die, a horrible bloody death. But you'll notice you can't jump or anything. You can't do anything else. So that's what we're going to do next, as well as actually setting up the camera, because the camera doesn't really follow him when you run around. So click play button again to stop the game, and select main camera in your hierarchy here on the side. And you'll see in your inspector on the right-hand side over there, you've got this cam target and this little custom script that's attached here. This custom script, all you need to know is it basically tells the camera to follow a target. So we're going to set up that target now. You'll see it's currently set to none. So with the main camera still selected over here in the hierarchy, like that, we're going to click and drag on Soy Boy. Don't let go of your mouse button. And you're going to hover over the cam target down here, and you're going to release your mouse button. And that's going to set that actual value there. Let me just open this up a bit more for you guys. And that basically is how you set a reference to a value in the editor. And what it's telling this camera script to do is to follow that transform component on the Soy Boy character. So if you run the game again and run to the side, you should see that the camera will now start following your character around. So that's much better. So let's stop the game and save your scene. So that's Command S. For me, it's Control S. And that's basically it. You guys are now at the end of Demo 1. So I don't know if there's any questions. Tammy's got a microphone there, so
we have time for about 1 or 2 questions and a few-minute break. So if anyone has any questions, put your hand up and I'll come by with the mic and everyone can hear your question. You guys are absolute geniuses. This is great. I love it when you don't have questions. No, that's not true. If you really do and you're embarrassed to ask the question, it's fine. You can talk to him privately later. Let's just take about 1 or 2 minutes just to settle down and kind of if you need to catch up or anything like that. And I'll dial us back up in just a minute here.
If you guys do want to let me bring up any other code so you can catch up. If you missed out anything, just shout. I'll bring that up on the screen while we've got 1 or 2 minutes. So basically in the editor, select main camera. And then you're looking for your inspector on the right-hand side of the screen here. Right at the bottom, there's this camera alert to transform script. And it should be set to something like none at the moment. Let me just set it to none for you. So that's what it should look like. And if you click and drag on Soy Boy, but don't release your mouse button, and just drag over onto cam target, and then let go of your mouse on there, that's going to basically set the reference to Soy Boy. Okay, so right at the bottom, if you select Soy Boy, you should have this script attached here called Soy Boy Controller. If it's not attached, you can click Add Component, and then type in soy in that little search box, and then just click on Soy Boy Controller, and it'll attach your script. And then if you run the game, it should be working if you've already changed the code in that script. But not to worry if you guys didn't get there. There's also a starter project in the demo2 folder. If you go to File, Open Projects in your Unity editor, you can just navigate to, using the open, you'll find a dialog. You can go to Demo2, Starter, and Super Soy Boy here. If you load that, that'll get you up to speed where we are. But if you manage to finish the project from where we left off, it's fine to carry on from the starter project there. Just quickly, while we've got a moment, I'm going to show you guys something interesting. Remember, we added those public and private fields to our class. Now, if you make a field variable public, you'll notice that in the script, in the editor, it's actually surfaced these speed and acceleration values. So you can actually change them in the editor if that field is public. If it's private, they don't show up in the editor. So it's just a nice way of controlling your values in the editor. That's the difference between public and private with Unity. There are some other bits and more advanced things you can do with serialization and things like that. If you want to ask me about that, I'm happy to talk you through it later on in the session after this. All right, so I don't think anybody has really left, so let's carry on with the next section. So let me just get my slideshow up and running here. All right, so what we're going to do now is we're going to add some fun platformer mechanics to the game. So that's things like variable controlled jumping and wall jumping and wall sliding. So what are these things? So wall sliding, there's an example there of sliding down a wall. We've got wall jumps where you can jump in between walls and sort of traverse high areas. And we've got controlled intensity jumps. So that's sort of controlling how high you can jump. So it's, you know, if you've got tricky platforms, we can control our jumps like that. So before we carry on, let's go through some basics of physics in Unity. So to use physics, you've obviously got to have world gravity. Now, by default, a project always has gravity set up to Earth-like gravity. So we don't normally have to worry about it. And then to use physics in your game objects need something called a rigid body component attached. Now, remember, we're working with a rigid body 2D in our game. So what that does is it allows your game object to be simulated in the physics engine. And Unity does that sort of automagically for you. As long as you've got that component attached to your game object, it'll simulate it in the physics world. You can also attach colliders, and that makes sure that your game objects will sort of collide with other objects. And you can define sort of bounding areas around your game objects with those. And you can work with physics materials too, so controlling things like bounciness and friction. That's optional. You don't have to do that, but it allows you to simulate those as well. We've also got a collision matrix to define what actually collides with different areas. And what you can do is you can set up things called physics layers. And to give you a practical example, let's say you've got a player in your game and your player can shoot bullets at enemies. What you don't want to happen is, let's say you spawn those bullets in the center of your player when you're firing your gun. you don't want those bullets to collide with the player because that's like shooting yourself, and obviously that's a bit stupid. So what you can do is you can set up a collision matrix to say, okay, all of the player game objects I don't want to collide with bullet objects. So the bullet layer and the player layer shouldn't collide with each other. But the bullet layer should collide with the enemy layer because you want your bullets to affect enemies. So that's what the matrix does. And of course, you can also handle collisions with custom game logic using callback methods if you've got a collider attached to your game object. So looking at Soyboy himself, we've specifically for physics, we've got rigid body 2D attached to him, which allows to simulate in the physics world, and we've also got a collider 2D. And it's a bit faint, but there's actually a green collider box around that object that defines a bounding area. And we can also handle custom collisions if we had any custom callback code that we wanted to do with that. So with that, let's continue on with demo 2. So back in the Unity editor, don't forget you can open up the starter project for demo 2 if you want to have a fresh start. If you manage to finish the last section, that's fine to carry on from where we are. What we're actually going to do is we're going to jump straight into our Soyboy controller. So if you load it up in MonoDevelop or whatever your code IDE is, and we're going to go all the way to the top here where we've got these public and private fields defined. And right at the bottom of the last one, we're going to add a new line. And we're going to do some stuff to control our jumps. So we're going to type in public bool, and we're going to call this isJumping. Don't forget your semicolons. And we're going to do another one, public float. Let me actually just bring this up a bit for you guys. And we're going to call this jump speed. And we're going to set that to a constant value of 8, f, for a float. And we want another one called public float jump duration threshold. And we're going to set that to 0.25f. Now this is going to be a threshold that allows us to define how long the player can hold down the jump key before to track how long the character in the game should actually jump for. So we need to actually time that and track it. So we're going to add another float below. We're going to call this private float, and we're going to call it jump duration. This is going to be like a timer. And then below that, we're going to add another one, public float air accel for air acceleration. I'll explain that in a moment, but just set that to 3f. And then below that, public float jump equals 14f. Again, these are sort of magic values. They're just what works well. I'll explain them as we use them. So what we want next is we want a way to actually detect if the player is on the ground or not to be able to jump. So we're going to add a new method into our script to handle this. So methods can go anywhere as long as they're in line with other methods. So I'm going to add this one just below our awake method. So just below that, add a few new lines. And this method is basically going to return a Boolean value if we're on the ground or not. So to do that, let me quickly explain to you what mechanism we're going to use to do that. And I've got a slide for this. So let's just go here. All right, so checking for ground contact, we're going to use something called ray casting. Now, this isn't Ray Wenderlich sort of casting a line into the ocean and fishing or anything silly like that. This is something in a physics engine that allows us to sort of shoot or fire an invisible ray through the world, and the physics engine will come back to us and tell us if that ray has actually intercepted or intersected another physics object. So we're going to be doing that, and if you look in this diagram here, we've got those 3 green lines. And what we're going to do, those are our actual ray casts. We're going to shoot 3 invisible rays below our character's feet. And they're very short because we only want to look directly below the feet if there's actually ground or a platform there. And what we're going to do is we're going to offset the other 2. So there's a middle one, the center one, and 2 off to the side. And that just gives us a higher degree of accuracy. So if you're standing right on the very edge of a platform, it'll still allow us to detect if the feet are there. So to do this, calculate where we need to start these sort of raycast lines from. We're going to use this component called transform.position. That's a property on the transform component that's attached to our game object, and it's got an x and a y value, basically where the object is in the x and y space. And what we're going to do is we're going to take that height value that we calculated, remember, in the initialization. And that height value is actually sort of half of the height. It's a bit misleading. I should have called it something else. But it's half of the height of the character. And we're going to add that 0.2f value for some padding just to get it slightly below the feet. So that's basically the position that we start the line from. And then in terms of where it is on the x-axis, we're going to take one in the center of the game object of soy boy, and then we're going to offset one to the left and offset one to the right. So that's basically how we're going to calculate that. So let's go back to our code, and below the awake method in soy boy controller, we're going to type in public bool, because this method is going to return a Boolean value, and we're going to call this player is on ground, and then just 2 parentheses here on the end, and then open and close braces. That's just to define a method that returns a Boolean value. And we're going to do a raycast. So we're going to type in bool ground check 1. So this is going to be our first raycast, is equal to. And we're going to use the physics 2D class there and a method called raycast. Now raycast needs, in this case, we're going to pass in 3 different values. An origin point, so where to start the raycast from, and we want a direction to say where this raycast should go in direction. And the third value is a distance value, so how far it should go before it stops. So to do the origin point, we're going to type in new vector2, and inside of that vector2, we're going to pass in transform dot position dot x, and then a comma, so we get to our y value for this vector2, and we're going to put in transform dot position dot y, subtract that pre-calculated height value. Okay, now let me just bring this down onto another line, because I know that screen space is a little bit limited. Okay, so, all right, I'll actually do that after I've written the line so you can see it. So after this component, we now need a direction. So after height, close parentheses, comma, we now need a direction. For that, we've got vector2, and we've got something handy to use called dot down. It's just a pre-calculated value that says, this is the direction we want down. And then we're going to go comma, and we're going to pass in this raycast length check, which is a constant value defined at the top of a class, which is 0.005 if you had to go back and look at it. But it's basically a very short distance that we want to look. And after the last parentheses, just end that with a semicolon. Okay, and I'm just going to bring this onto another line and bring this up here so that you guys can see it. So that's what our first ground check should look like. So we highlight that whole line, copy it, paste it twice. So we're going to make 2 copies of it. And we're just going to rename this to ground check 2 and ground check 3. And we're just going to vary the padding on the left and right. Remember, so the first ground check is our middle raycast, and now we're going to do 2 on either side. So to do that, we now need to offset our x position. So just after transform.position.x, we're going to add, and we're going to go in brackets width, subtract 0.2f, just for a bit of padding, and then close parentheses there. And then for the third one, after position.x, we're going to subtract, and then in brackets width, subtract 0.2f again. So that's going to offset them slightly. Now below those 3 ground checks in the same method, player is on ground, we now need to actually check them. So we're going to say if ground check 1, and then or is basically 2 pipe symbols like that, and we're going to say ground check 2, or, ground check 3. Now in C#, you can evaluate a Boolean value as true like this. You don't have to say equals true. You just put it in brackets, and that's the same as saying, are any of these true? Then we're going to return true. Don't forget that semicolon. So obviously that's going to return true if any of those ground checks come back as saying there's something there. Otherwise, return false at the bottom of our method. Now our method basically is now set up to return true or false based on whether there's ground below or not. So if you can just raise your hand if you managed to follow up to this point. Okay, great. So now we actually need to put this method to use. So to do that, we're going to go and look in our update method. Right at the very bottom, below that sprite flipping code, new line, and we're going to say if, open brackets, player is on ground. Remember, to a method call, you've got to put in the parentheses after that. So if player is on ground, so that's saying if it's true, and, so double and symbol, is jumping equals false. So if the player is not jumping, but if the player is not pressing jump, and the player's on the ground, then we're going to execute this block of code. And then inside here, we're going to say if, so a nested if statement, if input.y is greater than 0f, open up braces, and we're going to basically set our isJumping flag to true. And then below this if statement, the inner nested if statement, just add a comment here that says to-do animator is on wall false. Don't ask me why. You'll come back to that in the lab later. So below the outer if statement here, we're going to now check the jump duration. We're going to say if jump duration is greater than the jump duration threshold, close parentheses, open braces, input .y is equal to 0f. So essentially, if the jump duration is less than sorry, I'm an idiot. That should be greater than. So make sure if jump duration is greater than the threshold, we're going to cancel the jump. So input.y, if you remember, is always 1 when you're pressing jump. So if the duration surpasses the threshold, we want to cancel the jump and stop it. So that's why we do that. So once you've got that, scroll down to the fixed update method. Did everybody get that? Let me just leave it up on the screen. If you just raise your hand if you managed to get that jump duration bit. Okay. All right, so back down in the fixed update method, what we now need to do is add some velocity on the y-axis to our rigid body on our character to actually get him to jump. So at the very bottom of fixed update, we're going to say if isJumping, which is basically saying if that's true, and our jump duration is less than our threshold, close parentheses, and then we're going to open up braces, and we're going to say, then we're going to set our rigid body velocity manually here. So rb.velocity is assigned new vector 2, and inside that we're going to say rb.velocity.x as the x component. So whatever the current x velocity is, just leave it as it is, pass it in here, and for the y, we're actually going to change that to jump speed. So we're going to manually set that jump speed constant value into our velocity to force our character to jump. So at this point, save your script and return to Unity. I'll leave the code up over here. This is at the bottom of fixed update. If you just make sure you've got that, and if you can just raise your hand if you've got to the back to the editor again. Okay, and what do you guys think is going to actually happen if we try and jump now? Do you think he's going to jump up and come back down to the ground? So I think let's find out and see what happens. So back to the Unity editor. If you click on play in the editor to run the game, press spacebar on your keyboard to jump, and basically we're going to launch Soy Boy into low orbit. He's never going to come back down again. So that's obviously a problem that we've got to fix, and that's to do with our jump duration. We're basically not timing it properly. And we've got the conditionals around to check for that, but we need to actually time it. So switch back to your code, and we need to now calculate how long the player has been holding in the jump button. So you scroll up to the update method, and look for the sprite flipping code here. So just below that and just above this player is on ground check, so in between here, add a few lines, and we're going to say if, and then input dot y is greater than or equal to 1f. So if you're pressing spacebar, basically, jump duration, so inside the braces, plus equals, we use something called time.delta time. Now this is the delta time, the sort of interval between each frame of animation. It's just a timer that Unity keeps that you can utilize. And it's a very crude way of timing something that we're going to use here. It works for us in this case. So jump duration is a timer. We're going to increment it by this delta time every frame of animation. And to do, just add a comment below here called to-do animator is jumping true. We'll come back to that later. And then after this if statement, we're going to say else, open up braces, and we're going to say isJumping equals false. So basically, if there's no input, if you're not pressing spacebar, set the isJumping flag to false, make sure it's false. Add another comment here. Sorry about these comments, guys. To-do animator is jumping false. That's again for the lab. And then below that comment, to say jump duration is assigned 0f. So we're just resetting our timer back down to 0 if you're not pressing jump. Save that code, return back to Unity, and try jump again by running the game. Let me leave that code up just for anybody else to catch up. And if you try jump now in the game, you should find that he comes straight back down again to the platform. And if you quickly tap jump, you'll notice that he does a short jump. So let me just switch back there so I can show you guys. So there we go. You can jump up, and it does a long jump if you hold it down, but the threshold stops the jumping action after 0.25 seconds. And if you do a very quick jump like that, you can do a short jump. So that's our variable controlled jumping done. So let's stop the game at that point. And we're now going to do some air control. So let's switch back to our code. And to do that, we're going to now go to fixed update, our fixed update method. And we're looking for this line here, sort of 3 lines into fixed update, where it says if input x equals 0. We're going to change that to become, right at the beginning of that, we're going to say if, just add a space and say player is on ground. So we're going to call our player is on ground method to see if it's true or not. And, so we're going to add and, input.x equals 0. So if there's no input on the x left or right input, and the player is on the ground, then we're going to, inside of this, let's just go up here. So yeah, just change that one line over there to look like that. And at the top of your fixed update method, we've got var acceleration is assigned XL. We're going to now replace that with var acceleration is assigned 0f. And then below that line, we're going to type in if player is on ground. We're going to open up braces, and we're going to say acceleration is assigned XL. So XL is basically going to be our ground acceleration value. It's set to a constant value of 6f. So if we're not on the ground, so in other words, so say else, if we're in the air, we want acceleration to be set to our air acceleration value, which is half of 6. It's just 3. So if you think about it in reality, if you're in the air and you're trying to run in the air, you don't have much traction. So you don't want your x and y movements to be very much. So we basically halve it if you're in the air. So it gives you a little bit more realistic sort of air control. Okay, so with that done, let's get straight into adding some wall jumping. So for that, we're going to add a new method. So just scroll up, find your player is on ground method, and then just below that, so below the closing brace for that method, we're going to add a new method. We're going to call this public is wall to left or right. Sorry about the really descriptive names, some habit that I've got. Just at least makes it clear what the method's doing. And we're going to use a very similar mechanism with raycasting to determine if there's a wall on our left or right of our character. So again, we're going to use raycasting. So we're going to say bool wall on left. We're going to say is assigned physics 2D dot raycast. And then inside the raycast, remember an origin point. So that's a new vector 2. And we're going to say transform dot position dot x for our x value. And then we're going to subtract our width, our pre-calculated width from that x position. And then after that, we need a y value. And this is just going to be the center of the Sawyer Boy game object. So that's going to be transform.position.y. And then close that bracket for our vector 2. And then comma, which is now our direction we need to pass in. So remember, for that, we've got some handy helpers here, vector 2 dot left, because we're going to check on our left-hand side for you guys that, left-hand side. We want to look to the left for a wall. So vector 2 dot left, and then comma, and then raycast length check, passing that same very short length check. Close parentheses and semicolon at the end. Let me just drop that onto 2 lines so that everybody can see. Where should I split it? Let's split it over there. There. Yeah. Okay, so that's our left raycast. So duplicate that, copy and paste. And let's rename that to wall on right. And all we need to do here is we just need to add our width instead of subtracting our width. And we need to change that direction to vector 2 dot right. Okay, so below those 2 raycasts, we're now going to say if wall on left or wall on right. Then we want to return true. Otherwise, return false. Oh, I can't type all of a sudden. Okay, what have I done wrong here? If wall on... thanks. Oh wait, sorry, that's wall on left. Oh, thank you. That was very stupid of me. Thanks. So yeah, thank you very much. Don't forget to add a return value, what your method should actually return. That was a very silly error on my part. And I'm surprised I couldn't even see that. It's like that semicolon story. All right, so that's our wall to left or right check. Now we're going to add a convenience method just below this. This one's going to also return a Boolean value, and I know I do need to return bool. So public bool player is touching ground or wall. So it's going to combine our ground and our wall checks and return a Boolean value if either of those are true. So we're going to say if player is on ground or is wall to left or right. So we're going to call both methods and say if either of those are true, we're going to open up braces, return true. And then otherwise, if none of those pass, then we're going to say return false. So it's a convenience method that calls both. And we'll use that in a moment. All right, if you just raise your hand if you've managed to get to that point and get that convenience method in. I'll leave it up a little bit longer for you guys to catch up. So what we're going to basically be doing now is we're going to use this to do our wall jumping. So it's going to help us determine if we're on a wall or not. Okay, so let us go down to our fixed update method. And what we're going to do, if you remember, right at the bottom of this class is a convenience method called getWallDirection. And this, let me just run through this quickly. This is going to return an integer value based on whether there's a wall on the left or the right. And if there's a wall on the left, we're going to return -1. If there's a wall on the right, we're going to return +1. And if there's neither, we're just going to return 0. And what this is going to allow us to do is when you're on a wall, we're going to basically reverse our direction. So we're going to take the negative value of whatever this method returns and multiply it by our horizontal movement to basically reverse them. So if you think about running into a wall, you want to then reverse direction, so you want to come back. So we're going to multiply it by the inverse direction, which is why we want 1 or -1. So to do this, let's scroll up to this comment here in the fixed update method where it says to do jump code. And we're going to replace that comment with var y velocity is assigned 0f. And then below that, we're going to say if player, and we're going to call this player is touching ground or wall, this helper method that we created, and input.y equals 1. So if the player is pressing jump and they're touching the ground or the wall, then we want to execute this block of code in the braces. And that's going to be just to set y velocity equal to our jump constant value for now. Else, so below that if statement, else y velocity is assigned the current rigid body velocity dot y. So just keep whatever the current velocity is y otherwise. Okay, so to actually jump off of these walls now, let's go down to this line here that says rb.velocity equals new vector2. We're going to pass in, instead of this rb.velocity.y value here, we're going to pass in our calculated y velocity. So make sure you update that line just to include y velocity. And then just below that, we're going to add a new line. So this is sort of towards the end of fixed update method, just above this if statement in here. So after we've set that rigid body.velocity, we're going to say if is wall to left or right, and we're going to put in an exclamation mark, and I'll explain why, and then just put in players on ground. So exclamation mark in C# can reverse a Boolean value. So if that comes back as, if player on ground is true, it's going to basically say, is it false? So we're just going to evaluate the opposite. And we're going to, after that, we're going to say and input.y equals 1. And then we're going to open up our braces. And then we're going to say rigid body.velocity. So we're going to set this manually, and that needs a new vector2. So new vector2, and we're going to pass in negative get wall direction. So we're going to call our wall direction. That's going to return 1 or -1 based on where the wall is, and then we're going to reverse that. So we're going to say, if it returns -1, we're actually going to be getting a +1 here. And likewise, if it's a +1, we will get a -1. And we're going to multiply that by speed. That's our constant speed value. and multiply that by 0.75f, a magic number. Now, if you think about jumping against the wall, when you come off that wall, you're going to lose a bit of energy. So it's just to simulate loss of energy by multiplying it down a bit with the 0.75 value. Now, we need comma, so we need a y component for this vector 2. And we're going to pass in the current rigid body .velocity.y. Okay. And then just below that, another comment, to do animator 1. And then after this if statement block, another comment. Sorry, guys, this is the last comment, I think. To do animator 2. That's for the lab later. All right, so as I explained, that's going to reverse our direction when we jump off the wall. So save your code, switch back to Unity. I'm just going to leave the code up for a few more moments for you guys to catch up. And if you return back to Unity and just raise your hand if you manage to get to that point. And yeah, let me leave it up. Basically, if you guys run the game now, you can essentially wall jump off of the wall. So if you bounce off against the wall next to you when you start off on the platform and press spacebar again when you touch the wall, you'll jump off and hopefully you'll be in the opposite direction. So I'm going to switch back to Unity now and demonstrate that. And let's just switch here. What I'm going to do is just make sure that the game launches in more of a full screen mode. So here's a platform here on the side. So if I jump and jump again, you'll see that he bounces straight back off again. And if you're pretty bad at this game like me, you probably hit quite a few. But using your variable control, see if you can try and get in between these blades and then jump over, and let's do some wall jumping up this column. And as you can see, you can basically scale walls and try and reach your prized bowl of noodles, which is the end of the level. And the level will just restart at that point. So that's essentially the character controller done with some advanced platforming mechanics. And you can basically try and complete the level in different ways and try out the different mechanics. So that's it for demo 2. Hopefully most of you guys managed to get to that point. If there are any questions, feel free to raise your hand and we can get a microphone over to you guys and ask away. Yes, up at the front.
Yeah, you like making me walk, do you?
I think we'll at least get it on the video if we've got the mic.
So I was just curious why you used raycasts to determine whether they were touching a platform or a wall instead of using another rigid body collider.
Okay, that's a good question. So I guess raycasting, we can be quite explicit about specifically where we send that ray out, so what sort of direction we send it in. If you're using a collider, you can get a collision contact point using a callback method. Now, these callback methods are available. You can use things like on collision enter, on collision exit, or on trigger enter. That's another one you can use. But you've got to then basically do a whole lot of tricky calculation to determine where that point is, and then work out where that point is in relation to your current position. And I guess you've got to do more maths. It comes down to that, really. Whereas if you're sending out a ray in a specific direction, you know that explicitly that's the direction you're checking. And you know that, like, let's say a wall's on the left for our left wall raycast. If that comes back as true, we know that we want to reverse our direction, so we want to go right. So it just allows us to be more explicit, I guess, and more accurate with our checking. Any other questions? I don't know what sort of time we've got left, if we've got any time to run through our lab. I think we do.
Yeah, we definitely have time for the lab.
Just important to note, you can obviously continue the lab on, if you manage to finish this project and get your character controller working, you can continue on the lab from there. Otherwise, there's a lab folder in the project files. Just go to the starter project and open up that in Unity, and you can follow the lab notes from the beginning of that. And I'll come around and see if anybody needs help now. But feel free to take your time and run through that. Hopefully I didn't miss out anything, but if you have got any questions later on after the session, I'll be available in the room opposite us to field any other questions, anything about Unity or otherwise. Okay, so let's quickly run through the conclusion. Hopefully you guys managed to get some time in with the lab. If not, there's always time afterwards. You've got all the materials to continue on with that. And I'll also be available in the room opposite during the next session. If you've got any questions, feel free to come up and ask them. I'm happy to answer stuff around building for other platforms, branching code, things like that. The asset store, I actually develop assets on the asset store, so if you've got any questions around getting content from there, just shout. So what did we learn? So in demo 1, we looked at some editor basics, how to use the editor, and we also looked at doing a really basic script to move our character left and right. We then went on to more advanced topics in session 2, and we looked at adding some fun platformer mechanics like jumping, variable controlled jumping, wall sliding, that kind of thing. And in the lab, we looked at adding, if you haven't finished it yet, you'll get to see this, but there was no wall slide animation. So if you were against the wall and you drop down, holding the direction into that wall, Soy Boy should convert into like a little sliding animation with his back against the wall. So in the lab, you add that. And add some other like jumping animations when he does that. So that's more to come in the lab if you still need to get to. So where to go from here? If you want to learn more, there's tons of free tutorials on raywinnerlich.com. I'm part of the tutorial team, and there's a bunch of us, some other really talented people on the team that are releasing some really cool content to go check out. There's also the Unity Games by Tutorials book. In that book, you'll learn how to create 4 games from scratch. One of them is Super Soy Boy, but you just do it from the start, so you don't have the sort of framework that we already had in place for this session. But there's some other great like tower defense games and twin stick shooter game and an FPS as well, so you get to see how to create those from scratch. There's also some really cool graphic content using Blender to create your own 3D models as well, which is really great. On Twitter, I'm at Shogan85 if you want to follow or ask any questions there. If you think of something later, feel free to do that. And again, just come back to me after the session if there's anything else. I'll also be around this evening and of course tomorrow during the conference. So with that, thanks very much, guys. Thanks very much.